When installing a step-up transformer, it's crucial to understand the fusing and protection requirements outlined in the National Electrical Code. Let's consider a scenario where you're stepping up from a 208 volts, 3-phase, 4-wire feed to a 480 volts, 3-phase, 4-wire system using a 75 kilovolt amps transformer. The primary side is 208 volts 3-phase delta, and the secondary is 460 volts 3-phase Y. Firstly, calculate the primary side current. You've correctly identified that the primary current is approximately 208.4 amps, calculated by dividing the transformer's volt-amps rating, 75,000 volt-amps, by the product of the primary voltage, 208 volts, and the square root of 3, which is approximately 1.73. This gives us 75,000 volt-amps divided by 359.84, resulting in 208.4 amps. Secondly, determine the primary side overcurrent protection. According to NEC Table 450.3, you need to size the primary overcurrent protection at no more than 250% of the primary current. Therefore, 208.4 amps multiplied by 2.5 equals 521 amps. This means you'll need to select a fuse or circuit breaker that is rated at or below 521 amps for the primary side protection. It is important to note that the incoming service does not necessarily have to match this exact rating, but it must be adequately sized to handle the transformer's load and any other loads connected to the service. Thirdly, calculate the secondary side current. The secondary current is approximately 90.3 amps, calculated by dividing the transformer's volt-amps rating, 75,000 volt-amps, by the product of the secondary voltage, which is approximately 480 volts, and the square root of 3. This gives us 75,000 volt-amps divided by 830.4, resulting in approximately 90.3 amps. Fourthly, determine the secondary side overcurrent protection. According to NEC Table 450.3, you need to size the secondary overcurrent protection at no more than 125% of the secondary current. Therefore, 90.3 amps multiplied by 1.25 equals 112.875 amps. This means you should select a fuse or circuit breaker rated at or below 112.875 amps for the secondary side protection. You should install overcurrent protection on both the primary and secondary sides of the transformer. Fifthly, consider the disconnect and fusing options. It is acceptable to install a disconnect switch on the primary side of the transformer and rely solely on fuses or a circuit breaker on the secondary side for overcurrent protection. The overcurrent protection on the secondary side will protect both the transformer and the primary side conductors from overloads and short circuits. In summary, you have 5 key steps. 1. Calculate the primary side current, which is 208.4 amps. 2. Fuse the primary side at 250% of the current, which is 521 amps. 3. Calculate the secondary side current, which is 90.3 amps. 4. Fuse the secondary side at 125% of the current, which is approximately 112.875 amps. And 5. Install a disconnect on the primary side and fuses on the secondary side. Remember to always consult with a qualified electrician to verify your calculations and ensure proper installation. Incorrect fusing can lead to transformer failure, fire hazards, and other dangerous situations. Proper overcurrent protection is essential for the safe and reliable operation of your step-up transformer system.